Hello, class. This is a video of the Chapter 12 sample problems, numbers 6 through 8. So I'm going to start off with problem number 6. We've got Gormley Precision Tools, and they make two types of tools, a regular tool and a high precision cutting tool. They manufacture the regular tool A6 on a regular machine only, but the high precision tool use a combination of both the regular machine and the high precision machine. So they've given us a bunch of information here, which I've already kind of copied over here in terms of the costs. Also, we have a capacity constraint on the regular machine for 50,000 hours. Oops, that one should not be, that should just be a number. There we go. And let's put it as a regular number. Okay, with the commas. Keeps adding. There we go. Anyway, so 50,000 hours. Capacity of the high precision machine is not an issue. So they have a $1.1 million fixed overhead budget here for the EX4. And of that, $600,000 is for lease payments here, okay, for the EX4. I'm just going to label that. All right. And they can cancel the lease agreement for the high precision machine at any time without penalties. Nothing else changes. So the one fixed cost that changes is that $600,000 lease payment. All right, so what we're going to do here is we're going to figure out what our relevant costs are here, and we're going to do this on a contribution margin basis. So we're going to start out by taking the contribution margin per hour of constrained resource. So, which is the regular machine. Okay, so we can use, so we have to calculate all of this. First of all, we have to calculate the contribution margin per unit and then convert that into how many hours it takes. So the selling price for each unit was 180 for the A6, which is from up here, and 280 for the EX4. The variable costs are listed here. We've got 120 and 20 on this side. And we've got 190 and 60 here. So variable manufacturing and variable marketing. So that gets us a contribution margin per unit is the sales price minus the variable cost per unit. And so that gets us, let's see, 180. Oops, what did I do there? 120. Oh, that should be 110. I got a typo. There we go. It's like those numbers don't look right. Okay, so per unit, we have a $50 contribution margin per unit. Now, 1 hour per unit means that it will effectively be, so 50 times, or 50 divided by 1 is 50. And here we've got 30 divided by 0.5. It's because it takes a half an hour for each of these. So 2 per hour, that makes sense, right? So that gets us a contribution per margin per hour for that regular machine of $60. All right, so we're going to plug that in over here. And then we have 50,000 hours total for these constrained resources. So we're going to figure out what would the total contribution margin be if we did nothing but make these machines on here. So 50 per hour times the, actually, I'll just do this with a formula. So $50 per hour in cell B16 times the units in B8 gets us to 2.5 million. Do the same thing here, except I'm going to put it to B8. There we go. So 3 million there for total contribution margin. So far it's looking like the precision one has more contribution margin here, but there's also that lease cost that is going to be incurred here. We do not have lease cost for the regular ones, and we do have a lease cost here. for the machine. So when we consider that, we end up with actually only 2.4 million. So when we consider those lease costs, it's actually looking like we make more money overall with the regular machines. So we should manufacture the A6 since the net relevant benefit is higher. The additional contribution from selling the EX4 rather than the EX6 is not enough to cover the additional costs of leasing the machine. Okay, so that's our first example there. Now they want us to look at this and say, hey, we can increase the annual capacity of our machines by 15,000 machine hours at a cost of $300,000. Should we increase the capacity of the regular machines by 15,000 hours? How much will our operating income increase or decrease? All right, well, let's take a look at this. So we're going to do the exact same formulas here. Contribution per margin per hour of the constraint, which will not change. It's the same contribution margin, but now we will have a different number of hours on this constrained resource. Adding 15,000 to our original 50,000 gets us 65,000. So that gets us a total contribution margin of, let's take a look. We'll put part one, part two. Okay, so 65,000, 65,000, make both of those. Let's format those with commas. There we go. So 3,250,000 and 3,900,000 less, once again, that same lease cost. Also, we have a cost associated with increasing capacity. That will happen with both of these, right? That happens either way if we're going up the additional 15,000. So we're going to take this minus 300,000 and minus 900,000. All right, so now we have enough with this expanded capacity, should have an E on the end of it. We actually are making enough to cover that 600,000 and the additional 300,000 here. So the relevant benefit here is 2,950,000, but over here it's 3 million. I think I forgot a zero there. Yeah, I did. All right. So in this situation, let's see here. We should increase the capacity. Yep. Our operating income will increase by $50,000. Whoops, hold on a second. 500, wait. $50,000, right? Let's do my math here. Yes, $50,000. I think this has a typo on it because it's saying 500. Yeah, there's a typo in this one. So just add the extra zero. The difference here is 50,000, not 500,000. So just be aware of that. Okay, looking at problem number 3 here. Oh, sorry. Yeah, no, I'm sorry. The 500,000 is from if we would have done it at the lower capacity, we would have 2.5 million here. Sorry, I'm looking at the difference between these two and misreading the question. So here, if we maxed it out, we would have made 2,500,000. Here, if we max it out, we would make 3 million. So the difference between those two situations is the 500,000. Yeah. Okay, that makes more sense. All right, now looking at part 3, suppose that the capacity of the regular machines has been increased to 65,000 hours, and they've been approached by Clark Corporation to supply 20,000 units of another tool for $240 per unit. So we're going to take this. Let me just copy these right down here. So we can add in another column here. I'm going to plug this in for product 3. It is going to sell for $240 per unit. They must accept the order for all 20,000 units or reject it totally. Okay, so it's all or nothing here. It's exactly like A6. This one is the A6, by the way. Except that its variable manufacturing cost is $130 per unit. So wasn't that our one before? We had 130 up here too. Takes 1 hour to produce 1 unit of V2 on the regular machine, and variable marketing costs are $20 per unit. So 1 hour of the variable cost per hour and $20. Okay. But let's see here. Oh, but it sells for 240 a unit. Yeah. So they make it sound like everything changes except for that, but it's, yeah. And variable marketing cost. Oh, okay, sorry. Okay, that's right. So instead of having this variable cost of 110 up here, it's 130. There we go. There. All right, there, plus the $20. So it's going to have $150. Okay, I knew based on that wording, there had to be some I was missing there. Okay, so that cost, the manufacturing cost goes up by $20. All right, so then looking at that, and we can make 1 per hour, I believe. 1 hour to produce 1 unit on the machine. Okay, so again, it'll just be that $90 divided by 1 is going to get us the variable of 90 here. So let's go down here and look at this. Okay, so we're going to calculate our contribution margin per unit of the constrained resource. Here is 50, here it is 60, and here it is 90. So 20,000 units, and we would be under the 65,000 here. Okay. So in terms of that, normally what we would want to do is pick the item that has the highest contribution margin per unit of constraint. Okay, so our regular machine hours are the unit of constraint here. So that's what we would choose because this one, this new product does have a higher contribution margin per unit. So we should accept that order. Okay, now we want to figure out an optimal product mix for the remaining items that will maximize our operating income with the decision that we made about Clark's order. Okay, so we have a constraint of 65,000 hours, all right? So typically what you're going to want to do is max out the items. So we're assuming we've already done this capacity increase to 60,000 or 65,000 hours. So that means that the machine lease for the EX4, it does still get considered because if we only do the A6, we would not need that, but we're ignoring that $300,000. So if we had that order, let me scroll back to that order. So 20,000 units. And so 20,000 units of Clark order. uses up 50,000 regular machine hour, or I'm sorry, 20,000 regular machine hours, right? So 1 hour per unit. So that means that we have remaining capacity of, if we're doing 65,000 hours, 45,000 hours left to allocate. And we're going to try and decide where we should use that. Okay. So with that, we're just going to do the same thing we did before, where we're taking our contribution margin per hour of constrained resource, and we are going to calculate our total contribution margin, and we are going to subtract out those lease costs. So this is exactly what we did before. Now we've still, once again, got the 50 and 60 for the contribution margin per hour, but our constrained hours are the remaining 45,000 hours. So now we want to figure out, of these two, which is the remaining. So if you have a 3 or multiple product mix, you say which one has the highest contribution margin per unit of constraints, whether it's machine hours, labor hours, what have you. You allocate as much as you can to the most profitable item at the maximum amount of that item you can sell. And then from there, you go down the list and you allocate as much as you can to all the remaining items based on their situations. So total contribution margin here is going to be 50 times 45,000. So 2,250,000. And over here is going to be 60 times 45,000. Oops, that was an extra zero. Hold on. There we go. So 2,700,000. And this is going to have no lease costs. This is going to have 600,000. So 2,250,000 here. This is only 2,100,000 when we subtract that out. So looks like what we would want to do then is we would still be looking at, well, let's see here. If we, let's see here. So we would want to do the, okay, oh, the V2 is the Clark one. So we're going to do all 20,000 units of that. And then we're going to do 45,000 units of this A6 and then no units of EX4. Now, when this would change potentially is if we're like, oh, we can only sell 35,000 units of A6 if we make them. We only want to make as many units as we can sell. So the first one, we know we can sell 20,000. We're going to make those. And then the next one, we would say, all right, either we want to max out and do everything if we can sell all of them, or if we can only sell a certain number, we don't want to make more than we can sell. So we would say, like, if we could only sell 35,000, we would put 35,000 here. And then the remaining hours we had left, the 10,000, would get allocated towards EX4, our next most profitable item. So you basically just keep prioritizing as many as you can sell of each item until you no longer have any capacity left to use. Okay. Okay, so for this next one, we're doing another comparison of whether we should make a capital investment. So we're looking at this again, no time value of money. We're just kind of doing this simplistically. So we make 7,500 modular computer desks per year, which sell at $750 each. Our current equipment, which we paid 1.8 million for, had a 5-year useful life, is 2 years old. It has a terminal disposal value of 0 and is depreciated on a straight line basis. So the equipment has a current disposal price, so we have to pay to dispose of it, of $450,000. And so we're looking at potentially upgrading this. Okay, so if we upgrade, we'll have one-time equipment costs versus replacing would be 4.8 million. We have a variable manufacturing cost per desk with upgraded versus replaced. And the remaining useful life either way is 3 years with a terminal disposal value. Okay, so we want to consider whether we should upgrade or replace and what would be the difference. So what we're going to look at here is we're going to look at our cash operating costs under each machine. So what does it cost us to operate these? We're going to look at what does it cost us to dispose of it. And then we're going to look at like what is the one-time equipment purchase cost here, right? Because that's the things that are gonna are one-time capital costs. Those are the things that will differ between our choices here. So our cash operating costs for operating the one. So we notice we have a very different variable manufacturing cost here. So if we're making 7,500 desks here, um, it's going to be $150 per desk times the 7,500 desks. And then, so that's 1,125,000, right? And then let me just double check my numbers here, 150 and 75. Oh, yes, and we have 3 years here too. So that's, don't forget to multiply it times 3 years. So we're looking at all 3 years. There we go. Okay, and then same thing over here, $75 per desk times 7,500 desks times 3 years. All right, so let's put some commas in here so we can read this. There we go. All right, so in terms of cash operating costs, 3,375,000 for replacement, 1,687,500. So the difference there is so it's basically half. Yeah. Okay. All right. So current disposal price. So if we upgrade it, we're not disposing of it, right? So we only have that disposal cost here. And it's 450,000. And then one-time capital costs to upgrade would be 3 million. 1, 2, 3, 4, 5, 6. Okay, count my zeros. All right, so we would have approximately 1.8 million there in difference. So it costs 1.8 million more. Oh, so I think by disposal price, they're meaning sale price, like what we can get for it if we sell it. Yeah, because otherwise having this as a positive, a negative cost doesn't make sense. Okay, so in terms of that, here, I'll just do the total here. Okay, so 6,375,000 over here. We've got okay, 6,037,500, right? And then okay, so a difference between the two alternatives of 337,500, which I could have also gotten by taking this column minus this column. So these difference ones are always the first column minus the second column here, right? To keep it consistent. This one is subtracting a negative, so it's adding it in. All right. Okay, so once we've got that, in terms of this, the costs so would be higher if we were to upgrade. So we should go ahead and replace. And let's see. So now suppose the one-time equipment cost to replace the production equipment is somewhat negotiable. All other data are given as previously. What is the maximum one-time equipment cost that we would be willing to pay to replace rather than upgrade? Well, basically what we're doing here is we want the cash cost minus the cash operating costs net of the disposal price, and added to the one-time capital costs. So add the actual costs, subtract the offset from selling off the equipment, and that needs to be less than or equal to the relevant costs here. So that's going to be right there, that one. Okay, so the maximum one-time equipment cost that we would spend then, we're going to calculate that by taking the, so we had a $337,500 benefit here, right? So what they're asking is like, when do we become ambivalent between these two? Well, when these costs are equal, right? So currently this capital cost is $4.8 million. If we add to that the amount that we are benefiting above and beyond the other option, which is the 337,500, that means that the maximum that we would be willing to pay is 5,137,500. And that's where we would be basically even between the two options. Okay, so now assume that the capital expenditures to replace and upgrade the production equipment are as given in the original exercise, so the same, but the production and sales quantity is not known. For what production and sales quantity would we upgrade the equipment or replace the equipment? Well, we would need to look at our contribution margin, right? But if we don't know the number of units here, then, and we have to think about this from a formula standpoint, essentially what we said here was that we would want to find where the cash operating costs plus the one-time upgrade costs was equal to the cash operating costs net of the disposal price, with the one-time capital costs added to it. And we said that the maximum we would pay there was that 5,137,500. So if you set those equal to each other, that would be the volume you'd be looking for. So the cash operating costs are equal to the variable costs times whatever number of units you're making. So let's see. So we've got that, and plus the one-time capital cost to upgrade is going to be equal to the variable manufacturing cost times units, yep, minus the disposal price. Okay, so that's this one, because this is the same thing. This is equal to equal. Okay, yeah, so this is the option one here is from here to here. And then the replacing option is this amount. So we're finding the one where those are set to being equal. Okay, so how many units would make that? Okay, so rather than walk you through all of this in the video as I typed it out, what I did was I took this formula right here and I made it into an equation, right? So I have the variable cost for upgrade, which is VCU times units, plus the upgrade cost has to be equal to the variable cost for replacement, VCR, times units, minus the disposal plus the replacement, right? Because what we're doing is we're going to this equation right here and setting them to find a number in to solve for the units that makes these two values equal, okay? So once we've got that formula there, I manipulated that to, I added upgrade to both, or I'm sorry, I subtracted the upgrade from both sides. So this next line you see, this one does not have upgrade on the left and it's subtracted over here. Then I subtracted the VCR times units from both sides, which gets the unit number on the same side of the equation for both of these. Leaving us with replacement cost minus disposal minus upgrade on the right. Then I isolated the units part out of here, right? So units times the variable cost for upgrade minus the variable cost for replacement should be, and then equals the replacement minus disposal minus upgrade, which are numbers there. So then to just solve for the units, I multiplied both sides times, or I'm sorry, divided both sides by the variable cost for upgrade minus the variable cost for replacement, leaving me with just units on the left. So that gets me to the replacement cost minus the disposal minus the upgrade, taking that number, dividing it by the difference in variable costs between the two. And when I run that math, it gets me to 18,000 units here. All right. So we had to do this one algebraically. Okay. Now let's see here. So looking at this, now we're going to start by calculating the operating income under each of these two alternatives here. And we're doing this under the original exercise, which would have been the 7,500 units. And we had a sales price of $750 per unit, which is 5,625,000. It's the same for both. And then we're just plugging in, let's see, so cash operating costs here. Dan Doria is Tech Guide's manager, and his bonus is based on operating income because he's likely to relocate after about a year. His current bonus is his primary concern. Okay, so which one is he going to choose? Okay, so scrolling up here to our, let's see, cash operating costs at, oh, sorry, cash operating costs are going to be based on, we got to calculate these based on our 7,500 units. So 7,500 times the, and this is only for 1 year here, so 150, right? So 1,125,000. And then here it's going to be 7,500 times the $75. So 562, 500. Our depreciation, we've got to calculate out here based on the useful lives. So let's take a look at that. We have so 3 years of useful life with no disposal value at the end of 3 years, we're assuming. So that's going to be depreciation here. We originally paid 1.8 million divided by 5. So plus the depreciation of the upgrade here, which is going to be 3 million. So 1 million for the, so this is like for the upgrade, and this is for the original machine, and then plus the 3 years. So I'm taking straight line of 3 years for the upgraded portion of 3 million. And then this is the original 1.8 million divided by 5. So adding those together gets us 1.36 million. Now on this side, we've just got the 4.8 million. So 1,600,000. So dividing it by 3 years over straight line. In terms of what we paid for it, we've taken 2 years of depreciation, giving us a net book value of 1,080,000, giving us a gain of 600 and, or sorry, a loss of 630,000 because we had book value of 1,080,000 and we only got 450,000 for it. So, all right, so total costs here then, when we add these up, 1,125,000 plus 1,360. It's a 2,485,000. And then on the other side, we've got 2,792,500, giving us a net of right and B. Okay. $3,140,000 and 2,832,500 here. Okay. All right. So operating income ultimately is better at that $7,500 or 7,500 unit production level. So we would vote to upgrade because it has a higher net income over a 1 year period. So if we're doing this based on Dan's bonus, he's going to pick to do the upgrade instead of replacing it. Okay, so this is an example of how management short-termism can cause different decision making than looking at something over the full life of the project.